Everyone thinks a better motor means better parts, but the winning motor deletes a part. One deleted piece is why brushed motors die and brushless spin 10,000 hours. That piece is the commutator and its brushes. This is not a niche debate. The same two motors are inside your cordless drill, your ceiling fan, every drone overhead, and the electric car in your neighbor's driveway. And picking one over the other quietly decides two things: how long the thing lasts and how often you fix it. So here's the real question this video answers. What does deleting that one part actually change inside the machine? Follow the current and the whole 10,000-hour gap explains itself. Start with the older design, the brushed motor. Picture a loop of copper wire mounted on a spinning core in the middle. Around it, fixed to the housing, sit permanent magnets. Run current through that copper loop and it becomes an electromagnet with its own north and south poles. Opposite poles pull, matching poles push, so the loop swings to line up with the fixed magnets. That swing is your spin. But here's the catch. Once the loop lines up, the pulling stops. It would just sit there. To keep it turning, the current has to flip direction at exactly the right instant, so the magnetic push always shoves the same way around the circle. Something has to flip that current over and over thousands of times a minute. In a brushed motor, that job is done mechanically. On the spinning shaft sits a metal ring sliced into segments, called the commutator. Two small blocks of carbon, the brushes, press against that ring from the outside and feed in the current. As the shaft turns, the ring rotates under the brushes, and every half turn the contact jumps to the next segment. That jump reverses the current in the coil at the perfect moment. Mechanical timing built from sliding metal and carbon. It is genuinely clever. A spinning switch that never needs a computer, never needs a sensor, just the geometry of a sliced ring rubbing against two blocks. That simplicity is exactly why brushed motors are cheap and everywhere. But look closely at how that switch works, and you can already see the problem coming. Here's where it gets expensive. Look at those two carbon brushes again. To feed current into a spinning ring, they have to physically touch it while it whirls at thousands of revolutions a minute. Sliding contact. Metal and carbon rubbing non-stop for the entire life of the motor. Three things happen at that contact point, and all three are bad. First, friction. Rubbing makes heat and it slowly grinds the brushes down, the same way an eraser wears away on paper. Second, sparking. Every time the ring jumps to the next segment, the current breaks and reconnects, and that tiny break throws a spark. Thousands of little sparks a minute, each one pitting the metal. Third, dust. The brushes shed black carbon powder that coats the inside of the motor. So the commutator is not just a switch. It is a wear surface, quietly destroying itself every second the motor runs. This is the master clock ticking down. Run the numbers and the brushes get shorter, the ring gets rougher, the sparks get worse, and one day the carbon is simply gone. Contact lost. The motor stops. And notice what's driving all of it. The wear happens because a part has to touch a moving surface to do its job. No touch, no wear. Hold that thought. So the obvious fix seems impossible. You need something to flip the current, and flipping it seems to require contact. How do you keep the switch but delete the rubbing? That question is the whole ballgame. So how do you delete the rubbing? You turn the whole motor inside out. That's the short answer, and here's what it means. In the brush design, the coils spun and the magnet stayed still, which forced the current to reach a moving part. The brushless motor flips that. Now the permanent magnets ride on the spinning rotor, and the copper coils are bolted to the outer housing, standing perfectly still. That fixed ring of coils has a name, the stator, because it stays put. Sit with what that swap just did. The coils are the parts that need current. In this layout, the coils never move. So the current only ever flows into stationary wires. Nothing rides against a spinning surface. There are no brushes because there is nothing for them to press on, and there is no commutator ring wearing down, because the whole rubbing contact is simply gone. Delete the part, delete the wears. But physics does not hand you a free lunch. Remember the job that clever spinning ring was doing. It flipped the current at exactly the right instant to keep the push going the same way. That job still has to happen. You cannot just remove it. The current in those fixed coils still needs to switch over and over, in perfect time with the spinning magnets. So the puzzle isn't solved yet. You've deleted the mechanical switch, but you still need the switching. Which raises the obvious question. If no ring is flipping the current anymore, then what is? Where did that job go? Here's where the job went. Out of the motor entirely, into a small electronic box called the electronic speed controller. Say it once and we'll just call it the ESC. Inside that box are fast electronic switches, and their whole job is to send current into one coil, then the next, in a rolling sequence around the ring. Energize the right coils in the right order, and the magnets on the rotor are pulled around in a smooth circle. That's the same flip the current trick from before, but now no metal is touching anything. It's done with electronics at the speed of a chip. But timing is everything here. Fire a coil a beat too early or too late and the motor stutters or stalls. So the ESC has to know exactly where the spinning magnets are at every instant. It does this one of two ways. Some motors add tiny position sensors that report the rotor's angle. Others use a slicker trick. The spinning magnets actually generate a faint voltage of their own in the idle coils, and the ESC reads that faint signal to figure out where the rotor is. Either way, the controller always knows the position, and it switches the coils to match. So the flipping still happens thousands of times a second. It just moved from a rubbing ring to a silent circuit. Same job, no contact. And that single move is what changes everything about how long the motor survives. Now the whole gap clicks into place. In the brushed motor, the commutator and brushes were a part that had to rub to do its job, and rubbing is a countdown. Brushes wear, the ring erodes, and the motor dies somewhere in the hundreds to low thousands of hours. That's the death clock we started with. Delete that part, move the switching into the ESC, and there is no longer any surface grinding itself away. So what limits a brushless motor now? Mostly just the bearings, the little rings that let the shaft spin freely. Bearings wear slowly, which is why quality brushless motors are rated for 10,000 hours and often far more. Same electricity, same magnets, wildly different life, all from deleting one rubbing part. But here's the honest trade-off, because there always is one. That electronic switch isn't free. A brushless motor needs its ESC, extra sensors or clever signal reading and more careful wiring, so it costs more to build and to buy. A brushed motor is just coils, magnets, a ring, and 2 brushes. Dirt cheap, and it runs off plain battery current with no controller at all. That is exactly why both still exist in 2026. You are not buying a better motor or a worse one. You are buying cheap and simple, or long life and controlled. The deleted part is the whole story. So there it is. Delete the mechanical commutator, hand the switching job to electronics, and the wear clock basically disappears. Here's your rule of thumb for the next drill or drone you buy. Cheap, simple, and disposable. Brushed is fine. Long life, high performance worth the extra cost. Brushless every time. Next up, one of those tiny position sensors uses magnetism to see a spinning shaft in total darkness. Want to know how it feels a magnet? That's the next box we open.